Hi everyone. In this video, let us discuss about depth limited search. Before that, in the last video, we have discussed depth first search. Let us have a quick recap of that. So both these algorithms comes under uninformed search strategies. So depth first search that is used to search from the initial state to the goal state by using the left hand side process. So first search full left hand side, and then if the goal state is not achieved, it will reach the other end. So but depth limited is different from the depth first search because it sets a certain limit for the search. For example, in this diagram, if we have, see, this is considered as level 0, this is level 1, level 2, level 3. So if we set the depth limit as level 2, means it is used to search only up to this level in the left hand side. If the goal state has not achieved, then it goes to the right hand side. Here also, if the goal state is not achieved, then it backtrace and finally find the goal state. So that's why without entering into the loop, it will find the best path solution for the problem. So it basically works into in the 5 steps. The first one is initialization. It will set the initial node and check the goal check, that is nothing but the goal node, and then limit verification. It is used to set a depth limit. After that, back tracing. So until that limit, if the goal is not achieved, it will back trace and reach the next state. So finally, termination conditions. So it is used to terminate based on 3 conditions. One is solution. Once the solution has been achieved, it will terminate, or else cutoff. That means depth limit. Once the depth limit is achieved, it will terminate, or else failure. If it fails to find the goal state within this depth limit, it will terminate. So these are the 3 conditions for the termination in the depth limited search. Let us consider one small example. So let us take this tree structure. In this, let us consider A as the initial state and F as the goal state. So with the depth limit, here we are given the depth limit as 2. So the first, so here there are totally how many levels are present from this is considered as level 0, level 1 and level 2, and this is the last level, level 3. But the depth limit is given as 2. So only up to this level we are going to search the goal state. So our initial state is source node is A. From A we have to check whether it is a goal state. This is not a goal state since F is the goal state. So we have to next move to next level. So here also we didn't find the goal state. So we have to move to the next level. So this here D is present. This is also not a goal state. So we have to move the next level. But the algorithm has the depth limit of 2. So we have to stop it from the level 2. And then we have to make a move to the next side of the parent B. So it goes to E. So next side, so this is he and this is not also a goal state. So it make a back tracing. So this step has been processed. So it back trace and reaches to the children of A. That is nothing but C. So this is also not a goal state. So next it comes to the next level. So and finally it reaches the goal state. So this is how the depth limit search algorithm works. So the basic path from A to F is A to B, B to D, D to E, E to C, and finally C to F. So this is the final path for reaching from the initial state to the goal state. So let us consider the advantages and disadvantages of the depth limit search algorithm. So the major advantages are it prevents infinite loops since it uses a depth limit. So the loops has been prevented, and the next thing is it has high memory efficiency and saves execution time because by using the limited search, and it is the foundation for the advanced search. And the major disadvantage are incomplete search. So since the depth limit has been fixed, if the goal state has not found within the depth limit, it fails to find the best solution for the problem. So that's why it's called as incomplete search and non-optimal output. it also not find the best path for the problem, and it also requires arbitrary guessing. And finally, the last step is the performance drops because of the limited search. So this is the total example advantage and disadvantages of the depth limit search algorithm. In the next video we will see about the next algorithm. Thank you.